This is lesson 2-3 about direct variation equations. A direct variation is a linear function defined by an equation of the form y equals kx, where k does not equal 0. And k has a special name. It's called the constant of variation. So when you see this phrase, constant of variation, that's what they're talking about is k. So this equation, y equals kx, that should remind you of something. It should look similar to something. And that thing is the equation y equals mx plus b, the slope-intercept form of a linear equation. A direct variation is also a linear equation. It's just a special type of linear equation. Notice that the k is in the same position as the m. So the k could also be seen as your slope, but in this case it's called a constant of variation. But look at what's missing. In a direct variation, there's no plus b. Remember that b is your y-intercept. It's where your line crosses the y-axis. Since there's no b, there's no plus b or minus b, that means it must be 0. And since your b is non-existent, and it therefore is 0, that means that a direct variation always passes through the origin 0, 0, because your y-intercept is 0. Example 1. For each function, determine whether y varies directly with x. If so, find the constant of variation and write the equation. Just write down the important information here. So first we want to determine whether y varies directly with x. What that means is this a direct variation? Remember that a direct variation is an equation of the form y equals kx, where k is your constant of variation. Being constant, that means it will not change. And they've asked us if it does vary directly to find the constant of variation. Again, that's your k, and then to write the equation. So an equation of the form y equals kx. By the way, here are some examples of direct variation equations. Y equals 4x, y equals negative 1/2 x, y equals 3/4 x. All of these are examples of direct variation equations. Notice there's just some number times x, and this number right here would be your k. So 4, in this case, negative 1/2, and then here 3/4. So in order to determine if y varies directly with x, we need to know, is the k constant? Well, how do you find k? So we learned about this in the last chapter. How do you solve for a variable? How do we get k alone? Well, this is k times x, so the opposite of multiplying by x is dividing both sides by x. So to find k, we're going to divide y by x. So that's what we'll do here to see if it's a direct variation. So I'm going to find k. So I'm going to take my y, 3, and divide it by x, negative 1. And then I'm going to do the same thing with this one. Y, negative 6, divided by x, 2. And again with this pair of points. Y, 15, divided by x, 5. Again, to know if y varies directly with x, the k has to be constant for all ordered pairs. And so we have to find the k for all our ordered pairs to tell if it is indeed a direct variation. So let's simplify these. 3 divided by negative 1, negative 3. Negative 6 divided by 2, negative 3. And 15 divided by 5, 3. Now, even though these are all 3's, they're not all the same. Negative 3 and 3 are not the same. Therefore, our k is not the same for all our ordered pairs, so it's not constant. So y does not vary directly with x. So our answer on A is simply no. No, y does not vary directly with x. Let's look at B. So again, to determine if y varies directly with x, the k must be constant in order for it to be a direct variation. So we need to find our k. And k is simply y divided by x, so we're going to do that for each ordered pair. Your y in this case is 14 divided by x, which is 7. Your y in this case is 18 divided by x, which is 9. And here your y is negative 8 divided by x, negative 4. Let's simplify these ratios to see if they're equal. 14 divided by 7, 2. 18 divided by 9, 2. And negative 8 divided by negative 4, and negative divided by negative is also a positive 2. So since our k is the same for all our ordered pairs, 2, 2, and 2, they're all equal, we know that y then, yes, does vary directly with x. So your first answer is yes. Yes, y varies directly with x. Then they ask for, if it does, so our answer is yes, find the constant of variation. Well, we did that. Remember that constant of variation, that's just k. So we found our k. K is y divided by x, which was 2. So our k is 2. And finally, they want us to write the equation. Remember that the equation for direct variation is y equals kx, y equals some number times x, and we found that number. That number is 2, so y equals 2x. And all three of those are your answers. Go ahead and try quick check 1, A, B, and C. Or let's just do quick check C, 1C on your own. So go ahead and pause the video and try quick check 1C on your own. And when you're ready, we'll resume and work it out. Okay, so again, they want to know, determine whether y varies directly with x. And what this phrase means is this group of ordered pairs, is this data representative of a direct variation? And again, a direct variation is y equals kx, where k is your constant that never changes. So again, we've got to find our k. To find k, to solve for k, divide both sides by x, and you get that k is the ratio of y divided by x. So in order to tell if this represents a direct variation, we've got to find our k for all three pairs of points. So y in this case is 5 divided by x, negative 9. Y in this case is negative 1 and 2/3 divided by x, 3. And then finally we have y, 3 and 5/8 divided by x, 6. Now, yes, you can get this, you can put this all in your calculator and figure it out, but I prefer working it out. So I'm going to change this fraction into a mixed number. 3 times negative 1, or 3, anyway, I know it's going to be negative. 3 times 1 is 3, plus 2 is 5, so negative 5/3 divided by 3, which can be rewritten as negative 5/3 divided by 3. Hopefully you remember that we cannot divide fractions, so I'm going to copy, change, flip, and change this to negative 5/3 times 1/3. And then when we multiply fractions, we simply multiply across. Negative 5 times 1 is negative 5. 3 times 3 is 9. So far, so good. Negative 5/9, negative 5/9. Finally, we'll do a similar thing on our last ratio. Change your mixed number into an improper fraction. 3 times 8 is 24, plus 5 is 29 over 8, divided by 6, which we can rewrite as 29/8 divided by 6. Again, we can't divide fractions, so we'll copy, change, flip, copy, change division to multiplication, and flip your fraction. To multiply across, 29 times 1 is 29, 8 times 6 is 48, and this I can't simplify. This is an odd number, and 48 is an even number. I could divide 48 by 2, but I couldn't do that to 29. Also, there's no way to turn 48 into 9. My denominator would have to be 9, and there's no way to get there. Same thing with 29, or with 5. So right here you can tell, since this last ordered pair doesn't fit, doesn't have the same k, that this is not a direct variation. Let's look and see if we can find one that is. I can already tell from this one it won't be. 7 over 6 is not the same as 4 over 3. So that again would be no. Same thing with negative 2 over negative 1, 2 over 1. Actually, none of these ratios are the same. So maybe A will be. Let's look at A. Again, to tell us y varies directly with x, that means, is it a direct variation? If it is, your k is constant. K is y divided by x. So we simply need to find our ratios for all three ordered pairs. So k is y, negative sorry, negative 2. Negative 2 divided by x, negative 6, which simplifies to be positive 1/3. Y1 divided by 3, which is the same as 1/3. And finally, y4 divided by x12 also simplifies to be 1/3. Therefore, our k is constant, 1/3, 1/3, 1/3. It is a direct variation, so yes. And if they had asked for the constant of variation, they didn't in this case. They just wanted the equation. If they had asked for the constant, though, your constant would just be k is 1/3. And therefore, your equation, y equals some number, that number being 1/3, y equals 1/3 x. Okay, example 2. For each function, tell whether y varies directly with x. If so, find the constant of variation. So something similar to what we just did, except now instead of with a table, we're given these equations. Again, they want to know, does y vary directly with x? If it does, they want the constant of variation, which again is just your k. So they're asking, is it a direct variation equation? Remember what direct variation equations look like. It's just y equals a number times x. That's it. We can't have plus anything else, minus anything else. It can only be y equals a number times x. That's it. And so we gave some examples of that earlier. So in order to see if a is a direct variation, I'm going to get y alone by dividing everything by 3. 3 divided by 3 is 1. 1 times y is y, and y equals 7 divided by 3, 7/3 x. 7 divided by 3 plus 7/3. So because of this plus 7/3, it is not a direct variation. Let's look at the next one. Again, I need to get y alone. So now it's negative 2 times y. The opposite of multiplying by negative 2 is dividing both sides by negative 2. Negative 2 divided by negative 2 is 1. So I'm left with just y on the right side. And 5 divided by negative 2 is negative 5/2 x. And this is a direct variation equation. We can flip the whole thing around using the symmetric property of equality. And y equals negative 5/2 x. So yes, this is a direct variation. Y equals some number times x. So our first answer is yes. They asked for the constant variation. Again, that's just k. And k is simply the number in front of x. So our number is negative 5/2. Great. Let's try some of those on your own. First, let's look at Quick Check 2a. So work through this one, and we'll go ahead and pause the video now so you can work on your own. Okay, so let's solve Quick Check 2a. Again, we want to know, does y vary directly with x? That means, is it a direct variation? If so, we want the constant. That's your k. So is it a direct variation? Y equals kx. This looks a little weird. There's not a number in front of your x, but we can rewrite this. Y equals x divided by 2 is the same as y equals 1/2 times x. 4 divided by 2 is 2. Also, 4 times 1/2 is 2. So you can see that these really are the same thing. X divided by 2 and 1/2 times x, those are the same. So therefore, our answer is yes, it is a direct variation, and the k in this case, our number in front of x, is 1/2. Let's look at B. Go ahead and do this on your own. Pause the video and play it when you're ready. Okay, so again, does y vary directly with x? That means, is it a direct variation? If so, find k. Our direct variation equation is y equals kx. Y equals a number times x. Can't have anything else. 2y minus 1 equals x. So we need to solve for y in order to see if it would fit this form. So first I'll add 1 to both sides to get rid of negative 1. Then we're left with 2y equals, these are not like terms, so we simply write them down. Divide both sides by 2. Then we have y equals x divided by 2 plus 1/2. Due to this plus 1/2, it is not a direct variation. Last one. This one looks kind of crazy. Let's see if it is in fact a direct variation. If so, we need to give the constant. So we have 5, 6x equals 1/3 y. We need to find out if it's a direct variation, which means get y by itself. So in order to get rid of this 1/3, I'm sure many of you are thinking, oh, it's multiplication, let's divide. But remember that you can't divide fractions, so instead we need to multiply by the reciprocal, which is 3/1, or just 3. 3/1, your 3's cancel, cross cancel, and of course 1 divided by 1 is just 1, so you're simply left with y on this side. 3/1 here, and you can cross cancel with your 3 and your 6. You can divide both of them by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, and you're left with 5 halves x. So your equation is y equals 5 halves x, so it is a direct variation, and your k is the number in front of x, 5 halves. Great. Let's move on. In fact, let's skip this one. You should see, because of this 10, that it's going to not be a direct variation. We can't have any other numbers besides the number being multiplied by x. Example 3. Now the wording here is really important. Pay attention to this, because on your homework tonight, you're going to have wording similar to this, and it'll be helpful to understand it. It says, the perimeter of a square varies directly. Now we've been saying this same phrase over and over. Y varies directly with x. Therefore, since they're saying perimeter varies directly, that makes our perimeter our y. Perimeter varies directly as the length of a side, so that makes side our x. Y varies directly with x. So instead of using y and x, they used p and s still, but we know it's y equals a number times x. In this case, since our y is perimeter, p equals a number times s. They gave us that important formula, p equals 4s. So if you're just writing important information, here's what I'd write. Perimeter varies directly with side. And then, of course, the formula, p equals 4s. And it relates the perimeter to the length of a side. So they want us to find the constant of variation. Remember, constant of variation, that's your k. Well, if your formula for direct variation is y equals kx, then your k is just the number in front of your x. In this case, our x is s, our side length. So our k is simply 4. No math to do there. And then B, find how long a side of the square must be for the perimeter to be 64 centimeters. So they're giving us perimeter, and they're asking us to find a side length. So S is what we don't know, P is what we do know. So we're simply going to substitute here. P equals 4S. P is 64 equals 4S. How do you get S alone? This is 4 times S, so the opposite would be to divide both sides by 4. And 64 divided by 4, 4 goes into 6 one time. 4 times 1 is 4. Bring down your 2, bring down your 4. 4 goes into 24 6 times evenly. So 64 divided by 4 is 16, and that's the length of your side. So the length of your side is centimeters, is 16 centimeters. That's your answer. Okay, let's look at Quick Check 3A. So go ahead and write this down. You can pause the video and try it on your own. Once you're finished with A, go ahead and do the other parts to this Quick Check 3. All right, let's look at Quick Check 3. So it says the circumference of a circle, circumference varies directly. Remember that sentence, y varies directly with the diameter of the circle, with x. Y varies directly with x. So you can see when they wrote our formula, your circumference is taking the place of your y in this equation, and your diameter is taking the place of your d in this equation. It relates the circumference to the diameter. What is the constant of variation? So again, your equation for a direct variation is y equals kx. So your k in this case would be your p. So your constant of variation is your p. On B, find the diameter of a circle with circumference 105 centimeters to the nearest tenth. Well, without knowing what this is, which means I forgot to write something down, we can't really do this one. So you should be able to do it. You know what this P is. That's in your book. So you know just to substitute 105 for circumference. Circumference equals, oh, I'm being ridiculous. What is P? P stands for pi. Oh, sometimes things are so simple you screw them up. Right, so this P just stood for pi. Of course, that's the formula for circumference. Circumference is pi times diameter. Makes sense. So that's your K. Your K is pi. So your circumference is your pi times your diameter. If you know your circumference is 105, we can find our diameter. The opposite of multiplying by pi would be to divide both sides by pi. So this, you'll need to just go ahead and put in your calculator so you can get the answer to the nearest tenth. And diameter is 105. Well, honestly, I don't know. Just use your calculator. I didn't bring one home, so I can't tell you. You can find this answer, though. Somebody smart. Tell everybody what the answer is. Okay, example 4. Suppose y varies directly with x. So they're telling you it's a direct variation. And then they're giving you this information. Y is 15 when x is 27. They're giving you a coordinate. Find y when x is 18. Okay, so they're telling you it's a direct variation. If it's a direct variation, then just like in example 1 when we had all those coordinates in a chart, we knew that the k was always the same. For it to be a direct variation, your k has to be the same. So again, how do you find k? K is y divided by x. So if your k's are the same, your k's are equal, this is a direct variation. Therefore, the constant for this ordered pair, your k for this ordered pair, and your k for this ordered pair are the same. Your k's are the same. If your k's are the same, then just substitute y divided by x. That means y divided by x equals y divided by x. So we're setting up a proportion. We're going to get a little more specific. I'm going to call it y1 over x1 so that I don't mix up my points. Equals y2 divided by x2. And so they gave you, and they told you, let x1, y1 be 27, 15. So this is my x1, y1, that labeling I'm so fond of. And this is your x2, y2. So then we just substitute. y1 is 15 divided by x1 is 27 equals y2, which is what we're trying to find. So y divided by x2, 18. Now reach back. How do we solve proportions? I hope you said cross multiplication. 27 times y is 27y. 15 times 18. 5 times 8 is 40. Carry the 4. 5 times 1 is 5. That's 9. 0 placeholder. 1 times 8 is 8. 1 times 1 is 1. 0. 17. Carry the 1. 270. Oh, look at that. We're going to get a nice clean answer. How do you get y by itself? Divide both sides by 27. And y equals 10. Good. Let's try that on your own in Quick Check 4. So go ahead and try Quick Check 4A. And when you're done, or pause the video, and then when you're done, play it. All right, again, they've told us, and it's not written here, but they've told us that it is a direct variation. So since these coordinates are in a direct variation, we know that their k is constant. The k for this ordered pair and the k for this ordered pair is the same. If their k's are equal, their constants are equal, that means that their ratio y divided by x is equal. So we're going to set up a proportion using these ordered pairs. y1 divided by x1 equals y2 divided by x2. So I'll call this my y1, x1, y2, x2. So y1 is 4 divided by x1 is 3 equals y2 is y, we don't know it, x2 is 6. And again, we solve a proportion by cross multiplying. so 3 times y is 3y, and that equals 4 times 6, which is 24. Divide both sides by 3 to solve for y, and y equals 8. Let's try that proportion one more time on Quick Check 4C. So go ahead and work 4C, pause the video. When you're done, play. Okay, again, we know that this is a direct variation. So since it's a direct variation, that means that the k must be constant. K equals y divided by x. Since these ordered pairs are in a direct variation together, that means that their k's were equal. K was constant. If their k's are equal, then their ratios y divided by x are equal, since k is simply y divided by x. So that's just some substitution there. So I'm going to set up my proportion with y1 divided by x1 equals y2 divided by x2. And I'm going to label my points so I don't mix them up together. So your y1 is your 10, x1, negative 3. This time we're trying to find x, so that's my x2 and this is my y2. So y1 is 10 divided by x1, negative 3. And that equals y2, which is 2, divided by x2, which is x, what we're trying to find. How do you solve proportion? Cross multiply to solve. 10x is equal to negative 6. And how do we solve for x? Divide both sides by 10. So x equals negative 6/10, which we can simplify to be negative 3/6. Okay, I think we've done enough of those. So your homework for tonight is whatever this page is on the board, all those odd problems, and your mixed review. So be good and do your homework. We'll have a quiz on this on Wednesday.